Dennis here from Respect Studios. Sorry about the last episode's audio. My voice was like crap. I mean, it didn't. You can't hear me very well, but this will be better. We're going to continue with the camera follow tutorial, and I'm actually going to make what exactly I was planning to make. So first we saw how we can make the camera. Actually, I have already made that tutorial, but the problem is that my camera recording software crashed, so I'm going to make it again. I'm not sure if I cleaned the code exactly as it was in the end of the previous tutorial, so you can pause here and see it. If it's different, you can just fix it. Now what we want to do at the moment, our camera is following the cube. If we slow him down, the camera slows down. If we speed it up, the camera speeds up. It always follows it. Now first of all, we're going to comment out the rotation following. We don't need it. We're going to make actually one new variable. First of all, actually, we're going to remove that. Let's make one object, empty object, and we're going to name it cam center. In the camera, actually, if I see, we don't need that now. New cam position. Yeah, we don't need that now as well, but we're going to leave it so you can write that line of code. Public vector3 new cam position equals new vector3 0 0 0. Here we need one public transform, which will be cam center position. This cam center position we're going to use to add that new empty game object to it. So we're going to assign it here, and in start, let's make a start function. We're going to say cam center position that position to be equal to target that position. So at start, we're going to assign the cam center position to be exactly where the target, where the player is. So there is it. It's exactly at the center of the player. And now in late update, now since we don't use the target anymore, we'll leave that for now. Here we will say new cam position that x to be plus equals to time that delta time, so the camera is speeding up, and we'll multiply that by 10 just for now, 10f, so it's float. And here where we are lerping from the current state of the camera, new position, vector3 that lerp transit position, target position, we're going to change target position with the new camera position. So now we're not following the player anymore, but the camera is just speeding up on itself. It's moving actually on itself. And we're going to make the new cam position private. Actually, we don't need it public. Now let's comment out the quaternion, the direction. We don't need this anymore. Okay, what we want to be able to do now, okay, I got an error because I didn't comment on the lerp of the quaternion. What we want to be able to do now is, if the player is speeding up, the camera should be speeding up with it. If the player slows down, the camera should be slowing down with it. But if the player slows down a lot, the camera should be continuing. So if it follows it for some time, but then it loses, then it loses it. So in the update, we're going to make, actually no, we can make new update. So here we're going to make float target offset. Can I see if I'm using that? No, I'm not using it. it will be equal to cam center position dot x minus target dot position dot x, and we're going to need that not dot x but dot position dot x. So we're going to be, let me just semicolon, let me just print the target offset so I can see what's going to spit out. So if the player speeds up, yeah, actually we're going to make target dot position dot x minus camera center dot position dot x. So this way we can have the negative value when the player is slowing down and positive value when the player speeds up. And now we're going to get this target offset, and actually let's move that above the new camera position, and we're going to multiply that to the time delta time with which the camera is speeding up. So now you can see, let's actually not declare that here target offset, but declare it here and make it public just for a second, so we can see how fast the camera is moving. I'm going to lock down for a second. Let's take the player and slow it down. You can see camera slows down. If we speed it up, the camera is speeding up as well. So to make the camera and the player move at the same speed, we're going to multiply again time delta time to 10, and then we're going to multiply the target offset. This way we can have the camera and player to be moving with the same speed, and now you can see the target offset is 0.9. So if we speed up the player, camera is speeding up with it. If we slow it down, camera slows down with it and even starts moving backward. Now our idea is to make something like what you can see in Badland or Crossy Road, where the camera is eating the player if he slows down too much. So right here after the target offset, we're going to make target after we get the position of the player accordingly relatively to the camera center position. We're going to say target offset to be equal to mathf.clamp target offset 0.5, and we're going to make 50 for the maximum. Now we're going to clamp the camera to the minimum speed of the camera will be 0.5. So if the player slows down lower than 0.5, the camera will continue and will not follow it. And let's make it even 2, so you can see it better. Now you can see the target offset here, and target offset, let's set that to 1 at the beginning. Oh, it's because it's 2. Let's make it 0.5, because it's too fast when we, yeah. Oh yeah, it has to be between 1 and 0, because if it's more, if the lower speed is more than 1, we're actually multiplying that with 10, and it's getting too speeded up. So So we're going to say between, the minimum should be between 0 and 1. If it's 1, the camera will not slow down lower than the actual start speed, and if it's 0, it will stop, but will not go back. So let's say to 0.5. Let's set it to 0.5. Now if we start, the camera is moving with the player. If we speed up the player, the camera will speed up with it. If we slow it down, let's say we slow it down to 1, yeah, so the speed is 10, the actual speed. So if we multiply 10 to 0.5, if the player the player speed goes below 5, the camera will start leaving him. So you can see the player speed is 3 now, and the camera is going to eat him. If the player is above 50, he's actually going to let's make that 5. Let's make the player faster, and if we make the player above 50, it will speed up and the camera will lose it. It's because we're multiplying by 10. If we remove that here, actually we can't, because actually let's try that to see what will happen. Well, we have to leave the speed to 50, so it's greater. So we just have to make the camera's lerp speed to be greater, like 100. No, that doesn't work. So we have to leave that 10 there. But since you're multiplying with these values, with the target offset, we have to make them 0.5 to 5. And now you can see that it's just a concept, you know. You can tweak it to make it better. So the camera follows the player. If he speeds up above 50, camera is going to lose him. If he slows down below 5, camera is going to eat him. So this is the range of the speed that we need to have it. So that's it. I hope you enjoyed it. I'm sorry for the confusion. Sometimes I'm making the tutorials from scratch. I'm not looking from anywhere. So thanks for watching. If you like it, subscribe. There will be more tutorials soon. And bye.